A high-end residential environment presents a complex, high-stakes topography of distinct materials. Navigating this environment is an exercise in applied chemistry and physics. A professional technician must account for the specific molecular behavior of every surface. The true nature of any surface is hidden at the microscopic level. What appears perfectly flat to the naked eye is actually a jagged landscape of micropeaks, valleys, and deep capillary pores. This microstructure determines the material's chemical tolerance. It dictates exactly how the surface will react to varying levels of acidity or alkalinity on the pH scale. Simultaneously, this physical structure dictates the material's mechanical durability against abrasion and friction. To manage this overwhelming variety, the house cleaning technician methodology breaks down residential surfaces into 4 distinct structural classes. This allows a technician to accurately predict a material's vulnerabilities. Accurately identifying these substrates before acting determines whether a surface is preserved or permanently damaged by a chemical interaction. The first material class comprises geological and ceramic substrates, beginning with natural stone. In this simulation, we see chemical vulnerability. Calcareous stones, like marble, causes immediate, irreversible etching, literally dissolving the top layer. Manufactured tile presents a different set of variables. The most common varieties include ceramic, porcelain, quarry, saltillo, and terracotta. Porcelain and ceramic feature a vitrified glass-like matrix that blocks liquid. Contrast this with quarry, saltillo, and terracotta. Lacking glaze, they possess a highly porous structure. These tiles mandate neutral cleaners and rigorous moisture control, preventing liquids from pulling soils into the substrate. Concrete and grout share this vulnerability. Both are heavily porous, cementitious substrates. Because cementitious materials are inherently alkaline, acidic cleaners will break down their structural binders over time. Therefore, alkaline extraction protocols are mandatory for deep soil removal. Moving to organic and fibrous matrices, the primary threat shifts away from extreme pH and focuses squarely on moisture sensitivity. For hardwood flooring, moisture is the critical enemy. If liquid penetrates microscopic breaks in the protective polyurethane layer, organic wood fibers beneath will swell and warp. Cleaning protocols must minimize liquid dwell time. This prevents hygroscopic expansion and protects the vital finish from abrasive wear. Laminate flooring, by contrast, is entirely engineered. It consists of a synthetic photographic layer bonded tightly over a high-density fiberboard core. Laminate's critical weakness lies at the seams between planks. A water droplet seeping into this joint causes the surface layer to violently peel upward. Liquid pooling at these seams causes irreversible delamination. For technicians, this dictates strict near-dry cleaning methods. Carpet operates on an entirely different mechanical principle. Functionally, it acts as a massive, 3-dimensional sink for dry graticulates. Because different carpet fibers, like synthetics versus natural wool, possess strict pH limits, aggressive dry mechanical extraction or deep vacuuming is a mandatory requirement long before any chemical intervention is considered. The third category, polymeric and composite surfaces, covers materials engineered for specific aesthetic and functional purposes, primarily worktops, cabinetry, and resilient flooring. Modern cabinetry and engineered worktops have a layered nature. Beneath polished exteriors lie vulnerable cores of fiberboard and structural resins. Delicate exterior layers, like thermofoil, are susceptible to chemical burns from harsh degreasers. The required protocol relies on mild surfactants and strictly non-abrasive microfiber action. Engineered quartz worktops also fall into this category. While they mimic natural stone, their internal resin binder changes their chemical care requirements, making them sensitive to high pH solvents. Resilient flooring, which includes vinyl, linoleum, and rubber, presents a unique chemical profile. While resilient floors effectively resist moisture, the plasticizers that give them flexibility are highly reactive to solvent-based cleaners. Applying the wrong chemistry strips the material, inducing permanent brittleness. The final category encompasses precision and reactive surfaces. These are primarily found on vertical planes and specialized fixtures. Stainless steel appliances have a distinct mechanical vulnerability. The manufacturing process creates a directional extrusion grain. Any mechanical cleaning action must align exactly parallel to this grain. Wiping across the grain with aggressive tools carves jagged micro-scratches into the steel, permanently dulling the finish. Similarly, glass and metal fixtures, like chrome and brass, are easily micro-scratched by incorrect abrasives or quickly oxidized if exposed to extreme alkaline or acidic compounds. Shifting attention to vertical surfaces, paint and wallpaper demand distinct situational awareness. Paint finishes dictate the physical vulnerability. Flat paints act as porous substrates that trap soil deeply, while high-gloss paints act as precision surfaces that will permanently display even minor microabrasions from aggressive scrubbing. Wallpaper introduces moisture sensitivity. The adhesives holding it to the wall are water-soluble. Overwetting a vertical plane will reactivate the glue, causing the total failure of the wall covering. Pulling back from the microscopic details, we can view the entire residential environment as a singular, cohesive system. An HCT professional maps these concepts onto the physical space. The environment lights up: acid-sensitive marble, moisture-sensitive hardwoods, and abrasion-sensitive metals. This predicts vulnerabilities immediately, eliminating guesswork. The core formula remains: identify the substrate, calculate its weaknesses, and match the exact cleaning protocol. Mastering this material science guarantees both strict sanitary efficacy and the long-term preservation of high-value property. Continuous situational awareness and scientific rigor differentiate the certified HCT professional, ensuring every surface is treated with technical precision.